Hello everyone, in this example we're going to do something a little bit different and essentially do the inverse of one of the earlier problems that we were looking at. So in this example we were asked to find the amplitude, period, equilibrium, and equation of the following graph. And so here we can see the graph of some transformed sine or cosine function, and we're going to have to kind of work backwards to find its equation along with this other important information about our function. And one important thing to note before we even get started with this example is there's actually going to be infinitely many answers to this question, right? We're going to be able to view this as a transformed sine or cosine function, and there's actually multiple sine or cosine functions that would fit to this graph. All right, so in order to kind of work backwards and find the equation of our graph, we're going to actually find the amplitude, period, and equilibrium along the way. So let's go ahead and get started with that. And to help us get started with that, I want to bring up some of those notes we discussed in our earlier video. The amplitude is always the absolute value of that parameter A, right? A is like our vertical stretch, compression, or flip factor. And we can also find the amplitude either by looking at the graph or using our little formula, max minus min over 2. So if we use that formula or look at the graph to find our amplitude, we will essentially know the value of that parameter A. The only thing we might adjust is make it a negative A or a positive A value, depending on what else is needed to make our function fit the graph. So let's see, what is the maximum value of our graph here? It's positive 3. We have to subtract away from that our minimum value down here at negative 1 and divide that difference by 2. That simplifies to 4 over 2 or just 2. We can also probably visually inspect and see that the middle line or equilibrium is at positive 1. How far do we have to go from positive 1 to hit the maximum? Or how far do we have to go from positive 1 to hit the minimum at negative 1? Well, it's 2 in either direction, so that is our amplitude. All right, so up next is our period, and remember the period has that nice relationship with that parameter B, where that parameter B helps us determine the horizontal stretch or compression factor. So we have to work backwards here. In our previous examples, we knew what B was and had to use that to find our period. In this example, we're trying to find B, so we need to know what the period is in order to find B. In order to find our period, we have to visually inspect our graph. Remember, a period is how long it takes before our function starts to repeat itself. And we can see essentially what we were given was the graph of one period of our function. So that is from 0 to 8. So that means 8 must be equal to 2 pi divided by the absolute value of B. So now we can multiply both sides by B and divide both sides by 8. And we see that B is equal to 2 pi over 8, which simplifies 2 pi over 4. Technically, that's the magnitude of B. All right, so up next is our equilibrium or midline or midpoint value of D. We can just visually inspect that and see that it is 1. We can also use our little formula over here just to verify or double check our visual inspection. So the maximum is 3. The minimum is negative 1. 3 plus negative 1 is positive 2. And positive 2 divided by 2 is 1. So that matches up with our visual inspection. Our equilibrium is equal to 1. All right, so these really are kind of 3 of the most important pieces we need to find the equation of our transformed sine or cosine function. The next thing we have to decide is whether we are viewing this as a transformed sine function or as a transformed cosine function. And that choice is almost always up to us unless the instructions say make this fit a cosine graph or a sine graph. So the most general way we could write a transformed cosine function would look like so. And the most general way we could write a transformed sine function would look about the same. Just switch out your cosine with a sine. Okay, so the value of D we found will work no matter what our choice for sine or cosine is going to be. We may have to make some adjustments to the sign of the amplitude value or period value or A or B, make that negative 2 or negative pi over 4, depending on the next couple choices we make. One thing we also had not touched on is a horizontal shift to the left or right by C, and that'll also be determined by our choice of whether we want to work with a sine or a cosine function. So at this point, we have to make a decision. Does our graph look like a transformed sine function or more like a transformed cosine function to us? The way I like to make that decision is basically using the starting point of our given graph. And so here our starting point is at 0, 1. one thing to notice is our starting point is at an equilibrium or midline value, and we are increasing through that equilibrium. And so now to help us make our decision, we want to kind of think of that initial starting behavior and look at it and compare it to the initial starting behavior of a sine or cosine function. Just quick little sketches off to the side over here. Normally our cosine function looks like that for its first period, and normally our sine function looks like this. Right, so the behavior we can notice is that our cosine function we think of or can think of as starting at a maximum and decreasing, and our sine function starts at a midline or equilibrium and is increasing. Well, if we look at the behavior we described here, we're starting at the point 0, 1. That is our equilibrium or midline value, and we are increasing as we move past that point. And so because of that observation, that means that I think it's going to be easiest if we describe this function g of x as a transformed sine function. So our general sine function would look like a times sine of b times the quantity x minus c plus d. We have to be a little bit careful about a and b in here in a second, but our choice of the sine function allows us to not have to worry about that parameter c at all. We don't have to shift our sine function to the left or right to make the starting value match up with the graph we are interested in. So now what is our a value going to be? Well, we know our amplitude is 2, so our a value is going to be positive 2 or negative 2. If it was negative 2, we'd flip our sine graph over and be decreasing through the equilibrium or midline value. That's not what we have here, not what we want. So we have to keep it a positive 2. All right, so taking care of the a. What about the b value? Well, b is related to the period, and we found that our b value is going to be either negative pi over 4 or positive pi over 4. And here we're going to use the positive value of pi over 4 because, again, we don't want any kind of horizontal flip or don't need any kind of horizontal flip involved. So far we're looking like 2 times sine of b. b was pi over 4. We have to multiply our b value by the quantity x minus c, but we said c was 0 or it didn't matter, right? That's why we chose sine, so we didn't have to worry about a horizontal shift. Then we have to add to this our d value, our equilibrium or midline value, and that's just plus 1. So one answer to this question is the function g of x, which is given by the equation 2 times sine of pi over 4x plus 1, will match this graph perfectly. That is one answer to our example, but it is not the only answer. There's actually infinitely many other sine functions that we could also use to match to this graph, but all those are essentially the same as the sine function we have written here. Essentially, all those other sine answers are just going to be the same sine function, but we will have a horizontal shift that'll be one multiple of the period of 8. So we made the decision that, well, that looked like a sine function to us, and we found our equation for the corresponding sine function, but everyone's different. Maybe for some of us, we didn't see that sine function behavior. Maybe instead we noticed that, hey, this looks like a cosine function, or we just wanted to make it look like a cosine function instead. Well, we can still make it work for a cosine function. We're just going to have to change the value of some of our other parameters. So the first thing we're going to have to notice is, well, normally our cosine function starts at a maximum, but that is not what we're starting at here. Our maximum has been shifted to the right 2 units. So if we're using a cosine function, we're going to have to make sure our cosine function was shifted to the right 2 units. Well, what value of c do we have to impose in our general setup here to make sure our graph shifts to the right 2 units? We have to use c equals positive 2, or make sure we end up with that quantity of x minus 2 inside of those inner parentheses. All right, but now let's take it back to a and b. A is referring to our amplitude, or as a part of that. Well, we're going to kind of basically shift our cosine function to the right 2 units, so we still are going to start at our maximum. So we don't want to use a negative a value here. If we use a negative a value with our cosine graph, it'd flip over and it would start at a minimum instead. So our cosine function, we're still going to use that amplitude or a value of 2. Our b value is still going to be pi over 4. And actually, we could make it negative pi over 4 if we wanted to, because, well, cosine is an even function. So cosine of negative x is the same as cosine of positive x. So that actually won't have any effect here. But now we are going to have some kind of horizontal shift occurring, right? In order for our maximum to happen at 2, like we said, we had to shift to the right 2 units. So we have to have an x minus 2 in those innermost parentheses. Then we can't forget our equilibrium or midline value of 1. That's our constant term of d, or plus 1 at the end. So here we have another equation for g of x, very different from our first one, but will generate the exact same graph. And like our first one, if we take this pink g of x equation, our cosine equation, and shift it left or right by its period, we can get many other versions of the same equation, or a similar equation, I should say, that will generate this exact same graph.